This is the second video in the AWS Developer Series, AWS Lambda Testing Java Runtime. This video follows on directly from the first video, AWS Lambda Testing Go Runtime. Here is the link to that first video. And the second point is that it's an identical Docker Compose Docker Bridge network set up as in that first video for the Golang Lambda test. The first big difference is the way the Java code dependencies work out. So Java has this concept of a class path. We often put jars on the class path to handle dependencies. The next difference is we're extending our AWS ecosystem here. For this test, we're going to work on the presumption that our Lambda function is mapped to a Kinesis data stream. When data is input to the Kinesis stream, it triggers the Lambda function via an event. When a Lambda function is set up this way, the input to the Lambda function looks like this JSON that you see here. We will use this Lambda code we develop in this test later on to work with Kinesis data streams. Just to quickly review the way the code is laid out. So we have a top-level directory. In this directory we have another directory, lambda-1. This contains the compiled Java bytecode for our Lambda function handler. We have another directory, lambda runtime mock. In this directory we find the code that provides a mock of the actual AWS Lambda Java runtime. And we have a Docker Compose file for our Localstack container and a Docker file that we will run our test inside of. Inside our Lambda runtime mock directory, we have a source directory and a build file and a jar file. Lambda sandbox Java gets mapped into our runtime image, and it provides a mock of the actual AWS Lambda Java runtime. The code in this directory is the compiled code of our Lambda handler. We compile it and build it and map it to this directory. There is a lib directory where all the dependencies that the code relies on. It's important to note, when we build the code, we don't create an explicit dependency in the code to the lib directory. The jars that are in the lib directory are getting added to the class path at runtime by the Lambda runtime agent. Now we can see how the Docker file, as a multi-stage build, is going to take advantage of the artifacts in the various directories. So in the first stage, it's going to build the Lambda runtime mock using the build.sh build file and rebuild that jar. So every time we build the image from scratch, it's going to rebuild that Lambda runtime mock jar and then copy it into the image using a Docker volume as shown here, where we bind the directory with our compiled Lambda function code to the var \task directory in the running container. This is shown in the full Docker command, which we'll explain more later. When we send that Kinesis JSON to our Lambda function, everything's going to trigger, the Lambda function is going to execute, and we're going to see some output. This is the Docker Compose file we are using to build and run our Localstack container. In the environment, we have this AWS CBOR disable variable, which we've set to 1. We don't strictly need it for this test, but for anything Kinesis related, we do need it. So I pointed out now, so we're using a Kinesis event JSON as input to our Lambda function, and in the next video we're going to start working with Amazon Kinesis. In the Compose file for Localstack, we just create one service, S3, as our Lambda Java function is going to push data to an S3 bucket. In this Docker Compose, we do not declare a network to demonstrate the default behavior. Compose creates a default network bridge for us anyway, which we can use. These are all the commands we will use to set up and run the test. So first we boot up the Localstack container with Docker Compose. We look at the networks and we will see we have this default network, run default. When we inspect run default network, we will get the JSON code as before. We locate the containers block. We can find the IP for Localstack, which we can use in our code. After we've built our docker-lambda Java container, we can run it with the default network and the Localstack containers IP as an environment variable. So we docker run, we set a Localstack variable with the Localstack IP, and we declare the network as run default, and then we pass in the Kinesis event JSON as an argument to our Lambda function handler, which in this case is Kinesis Lambda handler S3. pushes data to S3. So we'll just demonstrate all these commands now, show how you can run the test. We bring up Localstack with Docker Compose up. When the mock service S3 has been created and Localstack is ready, we're going to look for the network. So we run the command docker network ls. That shows us all the available networks, which the default network was created is called run default. When we inspect run default containers block, we can find the IP as before. With this IP, we're ready to set up the command to run the Docker container with our test. With the parameters for Docker as described, we run the test and we should see output like this. Lambda handler function successfully parsed the JSON, processed the JSON Kinesis event, extracted the data, and pushed it to S3.